this session. So welcome everyone who has already joined and is signed on to today's Reactor session, which is AI on the Microsoft stack. So you're very welcome to this morning's session and from wherever you're dialing in from. Today's speaker is Hank Bowman, who is a cloud advocate at Microsoft. So we're very lucky to have Hank delivering this session. To give you a bit of background about the Reactor, for those of you who don't know so much about us. So Reactors are community hubs for startup and developer communities to learn and connect. So Reactors deliver lots of training workshops, presentations, industry speakers that are all aimed at building and upskilling developer and startup community groups via emerging technologies. So Reactors are physical spaces, and we're based all across the world, where we usually host events, but obviously given recent circumstances, we're moving to more of a online presence instead. So hence our online activity, for those of you who've seen that on Meetup. So getting back to today's session, it's an hour long. It will be recorded, and the recording will be available within about 48 hours after the session. So what I will do is post that link on the Meetup Reactor London page, just in the event page. That's where you'll be able to access it. And there is Q&A opportunities today. So any questions you have throughout the session, please feel free to ask them in the Q&A section, and we'll make sure that all questions are answered by the end of today. So without further ado, I will hand over to our speaker. Hank, if you'd like to kick us off.
Yes, hello. Thank you for having me, and welcome to the session AI on the Microsoft stack. My name is Henk Bowman, and I'm a cloud advocate at Microsoft, and I'm based in the Netherlands. And today I'm going to talk to you about what the Azure Cloud offers you in the subject of AI. And our agenda will look like this. We're first going to do a brief overview of what components are available and where you can use them for. And then we are going to explore some cool cognitive services. So to start with, I really want to talk a little bit about what AI and machine learning is. So for me, I always find that the easiest way to explain it is that we give the computer the ability to learn things without explicitly programming it. So instead of writing lots of functions like I did as a developer in my previous days, like a lot of if then else, I give it a lot of data. I select a training algorithm, and the computer will come up with a function for me. So let's see what is available and how we can create those functions. So we have a first layer that our sophisticated pre-trained models. That sounds very expensive, but basically it are cognitive services. Basically, they are machine learning algorithms that we at Microsoft have trained, exposed through an API. So everything is maintained by Microsoft. The speed, the fairness of the models, how they work, how they're load balanced, security, everything is handled by Microsoft, and it is available for you by just calling an API. But sometimes you need to do it yourself, and then you have to pick a training framework. So the Microsoft Cloud supports all popular frameworks. So if you want to train your models in PyTorch, TensorFlow, Keras, Onyx, it is all fine. It will all work. We can make it a little bit easier for you to train your own models because we have Azure Databricks to help you doing data processing. And there is Azure Machine Learning Service, which will manage your machine learning lifecycle from data up to running it in production. We also have machine learning virtual machines. And these virtual machines are really handy because if you start with machine learning, you need to install a lot of things on your machine to actually get it running. And even if you want to train on your GPUs, then it can take a lot of time to get started and actually do the thing you want to do. So we have machine learning virtual machines where we're taking care of all those things. All the frameworks are installed, all the GPU drivers are installed for you. So it works out of the box. So that is a really great way to get started. And then finally, we have powerful infrastructure. If you want to train your model, if you need to train your model, you need either GPUs or you need CPUs. So for instance, from Azure Machine Learning Studio, you can create Azure Machine Learning Compute based on a CPU cluster or a GPU cluster. Then when you have trained your model, we can also help you deploy it in the cloud. Use, for instance, IoT Edge to deploy it, to deploy your models on the edge, or we can just give you the model and you can run it locally. So, but today I want to zoom in to Microsoft Cognitive Services. So I already tipped it briefly. So Microsoft Cognitive Services are pre-trained models that can run in the cloud and on the edge. And they're divided in 4 main regions. So we have vision to make your application see. We have language to understand what is being spoken. We have speech to make your application talk and listen to you. And there is knowledge if you want to tap into the big brain of the internet. So I said, they run in the cloud. You can call them by just sending an API request. Or we can give them to you as a container, so you can run them on the edge, or run them in your own infrastructure, in your own Azure Kubernetes service, for instance. That is not available for all the cognitive services, but for instance, if you want to do face detection and you want to have it in your local infrastructure, you can get that container and run it. It does not mean it doesn't need a connection to the internet. So what a container does, it will ping back the cloud every time and will give you the billing to send the billing information. So you still have to pay for all the requests that come into that container. So first, let's dive into speech. So speech is there to convert spoken text, spoken words into text, and again, speak them. So there are 4 main categories in this area. There is text to speech, there is speech to text, there is speaker recognition, and there is speech translation. So let's zoom into speech to text. So speech to text is an API that can convert speech to text, meaning you can talk into the microphone and it will actually type what it is hearing. So you can do that in 2 different ways. You can call a REST API, just send some data, an audio file of 30 seconds to that API, and you will get text back. But it is better to open a WebSocket and start streaming the audio to that WebSocket. And then it can real-time listen to what you are saying, and it will actually subtitle it. I think you can even see it in PowerPoint, because that is also one of the services that is using this thing. And it can listen to you in 10 different languages. So let's show an example of what you can make, or what I made. So imagine there is an app. You have an app on your mobile phone. You record an audio file. You post that audio file to an API. The API that runs somewhere in an Azure Web App puts that audio file on a blob storage account. The cool thing is that if something is put on a blob storage account, you can trigger an Azure function. And within that Azure function, you can open a WebSocket to the Bing Speech API. So you will stream the audio file, and in the output you can write, for instance, in a Cosmos database. So now we have that speech to text, so it is in text. So we can translate that text from 10 languages, real time, to 62 languages. So it can listen to you in English, French, German, Italian, Russian, Spanish, and probably there have been added more every month. And it can translate it to you in 62 languages. So if you want to have yourself subtitled in Klingon, that is absolutely possible, because that is one of the 62 languages. So the next thing I want to dive into is the speaker recognition API. And this API is pretty cool because it can actually identify and authenticate people by a voice sample. So how does it work? You need to create a speaker profile first. And that is done by reading a few sentences. So, for instance, the sentence can be, "My voice is my passport, verify me." So what we can do is, with the first thing you need to do is load those phrases you can say, because you can't say any phrase to get that working. So you first do an API call and say load phrases. And then you get, the last time I checked, it were around 10 phrases you can say. Then you do another API call and you create a verification profile. And then you have to start enrolling yourself. Meaning you have to read that sentence 3 times. "My voice is my password, verify me." And then when it is accepted, you have your own voice profile created. And later on, you can use that created voice profile to verify if that person speaking is actually that person. So you have to record the same phrase, send it to the API, and then read the result from the API. And one thing, if you do it, be sure to send the correct audio format to it. So you need to send a WAV file with PCM encoding, a sample rate of 16-bit, and send it mono. So let's see if I'm sharing audio here, because I will show you a small demo from the app I made, which is available in my GitHub. So what I'm doing here is I'm creating a new profile. You see the GUID is created above. I'm reading my sentence, "My voice is stronger than passwords." See the API result at the bottom. It says it is enrolling. You need to do 2 more times, and I heard "my voice is stronger than passwords." I have to do it 1 more time. And then the result comes back and says, "Hey, you are enrolled." Then I can use it to actually verify my voice. So I select my profile ID. You probably want to store that somewhere in your Azure Active Directory. Read the same sentence. Send it to the API. And then we get back the result. Accepted with a very high confidence. So this sample app shows you with like 5 or 6 calls how you can implement voice authentication in your applications. So let's move to the next service, and that is language understanding, which is a big part of the Microsoft Cognitive Services suite. So what it can do is it can extract intents from sentences. So it is used in chatbots, but you can imagine as a developer, people can say a lot. People can say many things in different types. So do I have any comments? Are there any new comments? It actually means exactly the same. And as a developer, I would make a big if then else statements that just, if this is the sentence, then do that. If this is the sentence, then do that. If this is the sentence, then do that. So what Lewis can do for you is it can map all those sentences to a single intent. So in your application, you only have to say, if intent is comment, do this. So you can train your own Lewis language understanding service for your specific use case by just giving it a few examples of the sentence. So another thing it can do is it can extract entities from those sentences. So for instance, if I ask, are there any negative comments or any positive comments, it can extract like negative and positive as the sentiment. So now I can make a program that say, if intent is comment and entity sentiment is negative, then I will do this in my application. By just a few API calls and a nice interface where you can train this. Text analytics. Another very cool API that will help you with lots of things. So it can detect sentiment, key phrases, named entities in language and language from your text. So for instance, if I give this sentence, I had a wonderful trip to Kansas and enjoyed eating a good barbecue. Then it will tell me a lot of things about that sentence. For instance, it is English. It extracted the most important words from it, like it was about Kansas, it was about a wonderful trip, it was about a good barbecue. So yeah, so you have the most important things. And then it gives you the sentiment. Is it like a positive sentence or is it a negative sentence? Trying to match things to entities, like it found that Kansas is actually a location. So it linked it automatically for me to a Wikipedia article where it told me more about that entity, about Kansas. So what can you make from this? So what you see here on the screen is a logic app that listens to my Twitter feed. So it analyzes all the incoming feeds and searches for the text hashtag expertsliveeu. And it will do that every 30 seconds. Then it filters out all the retweets because we don't want to have that in our database. And then we will run sentiment analysis over that tweet. So we pick the tweet and we just say if it is positive or negative. So we want to have the sentiment and we store that in an Azure table. And this is how the table looks like. So we see that there's petition key, the row, the timestamp, and then we see the score. The score is between 0 and 1. So we see that there are a lot of positive tweets about Experts Live. So this is how easy and with almost no code you can make a sentiment analysis about, for instance, your event. So let's dive into the face features of the Microsoft Cloud. And that is one of my favorite parts. So let's talk a little bit about the Face API. So the Face API is an API that can detect, describe, and identify persons. It can also tell you a lot about emotions. So let's zoom into what you can all get from this API. So the first of all, you get bounding boxes where faces are in the images. So it all starts with sending an image to this API and then specifying what you want to get back. So the first thing you get back is the bounding box, and you see also all the dots on my face. It will also tell you, hey, this is the point of your nose, these are the edges of your lips, here are your eyes. So this information you can use to make the funny Instagram faces and so on. Put on fake glasses, put on fake mustaches, and so on. So you can get that back for around 30 people in a good quality image. And then for every face it finds, it will tell you a few things. It will do a guess of the age. For me, it is pretty good. It will tell you the gender. It will tell you if someone is smiling, what type of glasses someone is wearing. So it can distinguish to reading glasses, sunglasses, and it can also detect swimming goggles. It classifies your hair color, meaning it will not say, hey, your hair is brown, but it will say, hey, it is 99% sure your hair is brown, and I'm 96% sure that your hair is black, 31% gray. So it will classify your hair. This will tell you if you have to shave. So it was 40% sure I had a beard hair, I had a mustache, and that I had sideburns. I was not wearing makeup in that picture. And it can tell you some of the accessories I was wearing. So it's 100% sure I was wearing glasses. It can detect a hat. I think it can also detect earrings and so on. Then it will classify your the emotions it detects in the face. So I'm pretty happy. I classified happiness like with 83%, 16% neutral, and I was absolutely not angry. And then there is another very important aspect. It will tell you something about the quality of the image. So these images you can use later on to detect, to identify people. So I can have this face here of myself and say, hey, this is Hank. But you only want to train the Face API with good quality images, because if you send in bad images, it might misclassify and might not train your model very good. So these features like the blur, the exposure, the noise, how the head is positioned in the photo can tell you a lot about the quality of the image. So always check that first before you add that image to your face training database. So talking about training for recognizing people, it basically works the same as what we saw with the speaker recognition. So the first thing we need to do is register and role that person. And for that, we need to create a person group. So for every group you want to identify, you need to create a group. So this is just a name and you get back an ID. Then you have to create a person. So we create Hank, give the name and we get back an ID. And then we can start adding faces, photos of faces to that person. So we give the person group, the person ID and the image. So the thing is that we can add multiple face photos to that person. So I can do something from where I was a little bit younger, a little bit older, with a beard, without a beard. So the face recognition really picks up my features. And then finally, when we have done that, we have to train the person group. So every time you change or add something at a person, you have to retrain your person group. Then, when we want to identify a person, we have to send a picture to the API and ask, detect all the faces. All those faces generate temporary face IDs. And we can pick up those temporary face IDs and send them to an identify method. So we say, hey, look if you can track these temporary face IDs in this person group. And then it returns the person IDs. And with those person IDs, with those persons, I can store metadata like this is Hank, but I can also then pick up the person ID and look people up in my own database. So I don't have to store it in the cloud. Another very broad API is the computer vision API. And the computer vision API can look at images and can tell what is on the images, what is going on, give you insights in those images. So if I send this image to the computer vision API, it will tell me exactly this. It is a man jumping in the air doing a trick on a skateboard, which is actually very, very accurate. So let's have a look at this weird image. So is it a cat? Is it a dog? Is it a cat sitting on the dog? Is it a dog wearing a cat hat? I don't know. So let's see what the computer vision API made of it. So first of all, it saw the dog, and it told me where that dog actually is. You see the blue rectangle on the top right? It actually put the position where the dog is in the image. It gave some text. It is a dog. I'm 99% sure that it is a dog. It is an animal. It is sitting. Yeah, could be true. It is brown. It is small. And if you look at the bottom right, you see it is also seeing the cat. And the text is, it is a dog looking at the camera, which is actually pretty accurate. So that is one thing what this face API can, this computer vision API can do. So the other thing it can do is it can detect celebrities in the image and can actually in an image and can tell you where they are. So if you're famous enough, you will be in this computer vision API. And it can read text in images. So if you have typed text, you can just send that image to the API and you will get back a JSON file with where exactly which word is located, like the green borders, and where the complete sentences are located. It doesn't matter if it is upside down, left or right, tilted, it doesn't matter. You will get the bounding boxes back and it will read the text. It can do also the same with my handwriting. It can read it exactly live. Don't talk to me about live. It will tell me where the sentences are. This you have to have quite straight, not upside down, not really tilted. It is not doing a very good job yet at that. But it is recognizing in the latest update my handwriting perfectly. So all those cognitive services I showed you, they work with just calling a bunch of APIs. It is just sending a photo to it, recording an API, sending an image to it. But what if your use case doesn't fit in that? And what if you want to create a model for your very specific project, or if you want to classify Simpsons? So let's dive into this next service, the custom vision service. And the custom vision is an easy to use tool. It's an online tool to create your own custom image classifiers without doing the machine learning. So the only thing you are responsible for is creating a nicely balanced data set, which we will dive in a little bit later of what that exactly means. So how does it work? You get a data set. You get sample images, because if we flash back to the beginning of the presentation, I told you that machine learning, we have to give it data, and then it will create a function, a model for us. So we have to get our data. And there are two types of projects what we can make with custom vision. So we can make classification projects, and we can make object detection projects. So for a classification project, you need pictures with only that object in the picture. So either, in this case, either Bart or Lisa, and not both on one picture. The other one is object detection. And there we put rectangles around where these objects are in the images. So you can have multiple objects in one image. We upload them, we tag them, and then we get our model. How does classification works? So classification, you send in a image, it looks at the whole image, and it will tell you, hey, I'm 90% sure that I see Homer on this image. With object detection, it works like this. If you send this image, it will tell you, hey, I'm 82% sure that Marge Simpson is at this location in this image. So it can also detect multiple Simpsons in the one image. Another very cool feature about the custom vision service is that by default, you can publish your model as an API. So you just have to call again from your applications. It's just calling an API, but you can also export these models. So you can export the models to run natively on your iPhone or on your Android phone, Onyx, so it runs on Windows ML. And you can even get a Docker container with that model so you can deploy it into your own infrastructure. So this is really cool, because if you have exported these models, you don't need a connection to the cloud anymore, meaning that on my iPhone, I can run my trained models offline. So that also means that you don't have the delay of sending your images up and down to the cloud from a mobile connection. You have that model there. So it is just like milliseconds before you get your predictions out. So I think I've talked for almost 30 minutes now. So it is time to actually show you custom vision and how we can create our own classifiers with it. So let's do that. Or maybe first look at some of the questions. Yes, let's look at some of the questions before we go into this demo. And this session will absolutely be recorded. Your voice should still be recognized if you still have a cold, because it is looking for voice patterns, is what I've heard. What if I have a twin sibling? Yeah, you will have to actually try that. If you look identical, yeah, I don't know what happened. I didn't do that yet. So keep your questions coming, and I will look at after the demo again. So to get started, you have to go to customvision.ai. This is the website, and you have to create a custom vision endpoint in Azure. So for this to work, you need to have an Azure subscription. But there is a free tier for this. So you need to have an Azure subscription, but it will not cost you any money to play around with this. So what can we do? Let's have a look at how we can create a project from scratch. So let's start with a new project. So let's call this a Simpsons reactor. You can give the description, and then you select the resource you want to have it trained on, which resource, because you can give performance on the different type of resources. So there is a free resource, there is an S0 as you see here, and if I click manage resources, I will go to the cloud and will actually see those resources. Should be working. Hopefully we don't get the two-factor authentication. No. So here you see my custom vision Henk Boelman account, and here I can change the pricing tier. So this is actually free, and this will cost €2 per $2 per 1,000 transactions. You can't do much. It is just a thing that lives here in the cloud and takes care of the billing. So I have to select the right one. We can give it a description, and then we have to start making choices. The good thing is that almost everything you can change later on, except for the type of project. So you cannot switch between classification and object detection later, but that is a very broad scope. So classification projects train pretty fast, so we're going to do that. And I have already trained an object detection project, so we can look at it later on how that worked. So we choose classification. Then we have to choose the classification type. Are we going to do a single tag per image, or are we going to do multiple tags per image? Meaning, are we just going to say this is Homer, this is Marge, this is Bart? Or are we going to say this is a Simpson, this is Bart, and if we add Family Guy, this is Family Guy, and so on, this is Stewie. So we choose multi-class single tag per image, and then we have to choose a domain. So this system is using transfer learning, basically meaning there is already a model that can do a lot of things, and we're specializing it with our data set. So I can choose a few base domains here. Am I going to classify food, landmarks, retail, or the same with the word compact behind? And what does the word compact behind mean? So I told you can export these models. So you can only export models if you have chosen for a domain with compact behind it. So we are going to do a general domain, and we can change it later probably to a compact domain. These are a little bit more precise. The models are a little bit bigger and a little bit better. So let's choose the general compact domain. So we can have two types of export capabilities. We can have it for basic platforms like the TensorFlow CoreML, Onyx, the Docker container like I showed you, or let me show the device to you. We can actually export it so it can run on this IoT device, the Vision AI Dev Kit. So these are really cool devices because you can train a model here and then use IoT Edge to deploy it on this type of standalone cameras. But we are going to have see this. So we say create project. And a good thing to know is that everything you do through the interface, you can also do through a Python SDK. And the handy thing why I'm mentioning that is that because if you do and train your models from, for instance, a Jupyter notebook or a Python script, you can actually version that code and make this a repeatable process. So let's add some images to my workspace. So let's start with adding some images from Bart. So the only thing you do is you select the 50 images and say, this is Bart, upload it. So let's hope the connection doesn't drop while uploading. Cool, that is done. Let's say we will add some images from Chief Wiggum. So I'm uploading 50 images per class now. Okay, 59, 50, but around 50. And you see that in the images, I've used the object is nicely centered. It's always kind of in the center of the image. But you see I've used a lot of different backgrounds. So the last thing we want is that we create an object detection or a classifier that will classify my background instead of my object. So make the object in the center steady, use almost the same lighting and the same quality of images, and use lots of different backgrounds. So let's add a few images more. Let's add Dr. Hibbert, but from Dr. Hibbert we will do a few. We'll do a few. So let's hit train, quick train. And now it will start training our model. And let's hope it goes as fast as it always goes, because normally training a compact model is only taking a few 10-20 seconds. So let's see what we get. So according to these statistics, we have created a perfect model. 100, 100, 100. Perfect. But here we see that we have unbalanced data sets. So if you create a model, you should balance the data set, meaning that from every object you should have around the same amount of images. So let's add some more images for Dr. Hibbert. So I had 7. So let's go from here. Upload. So now I have some more untagged images. So I now can go to all the images, select them all and tag them, but I can also use this suggested tags option. And I just have to click on it, and it will automatically start tagging my images for it. So maybe it works. And yes, we see that it works. So it has found, it suggested that all these images are of Dr. Hibbert. So now the only thing I have to do is click confirm tags, and they're added to my training data set. Go back to the tagged images. Now we see that I have 74 images, 47 images of Dr. Hibbert. I can click train again. And now we should have a more balanced data set, more balanced model. Still complaining about the 3 images, but let's ignore it for demo purposes. So I did that a little bit too fast. So what we can do now is we can do a quick test. So we can either Google for an image, put the URL in here, or we can pick one of my test set. So let's go here, and you will see that. What did we actually train for? I think we did, right? Yeah, we did Bart. So it is 99.9% sure that it's seeing Bart in this image. Let's see if we also have a testing image of Wiggum. Yes, we have. And here we see it is 100% sure that it is Wiggum. But this model is not that difficult because it only has 3 classes. So I also have this same type of model, but then with all the Simpsons. So we can do a quick test. Oh, sorry, this is the wrong one. This is the object detection. We're going to dive into that later. This is the one with, this is the classification project. And here you see there is Bart, there is Marge, and so on. So this model is a little bit more complicated because it has more classes. So let's do a quick test against these models. So here you see, first of all, that we can test against multiple iterations of the model. So we will test against the latest iteration, and here it says it is Millhouse. And that is correct because I don't have Ned Flanders in this data set. So we can add that, we can add Ned, open, say Ned Flanders, upload him, and train it. So while it is training, we can actually look at what we have tested against. So it is taking a log of all the things that come in through the API, because the quick tests will also put it in the API. So, and then we can see here that it indeed classified this image as Millhouse, and that is what we don't want. So we can, from this interface, we can add these images to the dataset and tag them, like, hey, this is Ned. So sometimes if your customer images come in, you can go here and see, okay, yeah, it should have detected actually that, so let's add it to the dataset. So, but remember, I said balanced dataset. So if like 100 images come in, you don't need to add all those 100 images to one class. Keep it balanced. So here we see now I've done it with iteration 4 with actually Ned. So if we do now a quick test against iteration 4, we should be able to see Flanders, that it will detect Ned Flanders now. And it is 99.9% sure, and the rest not. So we can go back to predictions, iteration 4, and see here now the same results for the same image. So let's dive into the tab performance. So here we see the different type of training what I did. Here I've trained it with the general domain. Here I switched the general domain to compact. Here I removed a class, and here we added a class. And all these different iterations I can actually publish to a prediction endpoint. So I can publish these iterations to multiple endpoints. So meaning in my application, I can do some A/B testing between the different types, the different iterations of my model. I can, for instance, route like 30% to model that is produced at iteration 4 and 20% to iteration 3. Compare the results so I can see in production if the production which model is actually performing the best in production, because with a quick test you know it on your test set, not on the real world examples. So let's dive into a few. Could a custom classifier API be created for sorting bulk photos? Sorting of bulk photos be created? Yeah, you could. What solutions are available in object detection in video sources, not images? At the moment, not. This tool is not suitable for video unless you export your video to all single frames and run it through the models. Can we briefly show and share end-to-end architecture technology involved to computer vision in any AI project, please? Yeah, that will be a whole separate presentation. I have some, if you go to my YouTube channel, I have some videos about how detect fake packaging. So that is a whole end-to-end scenario using Azure Functions and Kubernetes service, training your own models. So I would highly recommend that. I will post a link later. So let's dive into object detection. So I have, yes, my model is finished. So object detection. So I have the same set of images, but now I had to select where all the objects are. And the result is quite different. So before it said, hey, I'm 99% sure that Ned Flanders is there. Here it will tell me, hey, Ned Flanders is there in 99.7% sure Ned is in this location. So the cool thing now is that it should also work with multiple Simpsons. So here we see it is detected Bart, at a high confidence Marge, Lisa, 30% Bart again, Homer 30%. So mostly I say everything above like 50% should work. So my model needs some work to detect Homer, but it is doing a good job for Bart, Marge, and Lisa so far. So let's look at another image, maybe this one. And here we see it is doing a way better job. It is way better job. Look at me. It's seeing Marge, seeing Bart, confuses Homer for Mr. Burns, and here is Lisa. It needs some work, probably it needs some more images, but it is working. And this also works with that you can get your suggested tags. Yes. So if you have any questions about custom vision, this will be the moment to ask me in the live Q&A before we move on to the next session. So while you think of your questions, I will actually show how you can export one of these models because I skipped that one. So we go back to our classification project that we trained with the general compact domain. So you click export, and here you can choose what you want. You can choose for the CoreML, the TensorFlow, the Docker file, or the Onyx file. So let's choose a Docker file. You can choose. You can even get them for ARM on the Raspberry Pi, for Windows, for Linux. So let's export this one for Linux. You have to wait a little bit for it to generate, and we download it. You can open this file. And then we see that this is in a zip file, there is the Docker file, there is the Azure ML, there is the scoring file, this will actually score against the model. And if we dive into app, we here have the actual model file and the file that will do the predictions. It is here the requirements file from which things needs to be installed in the Docker container. And here are the labels, which you can see are the same as the labels we have actually trained. And this is the small Flask web server where it will run in. Cool. So the next and final topic for today are cognitive services labs. So this is a separate place within the cognitive services. And this is the place where you can have a look at early emerging cognitive services. So product teams that are working on something new, something cool, are putting that there if it is in some kind of stable state. So you can play with it, participate in the program, and participate in the development of that specific cognitive service. So this is how the website looks. You go to labs.cognitive.microsoft.com, and there you can choose your projects. Some of them you can just download and use. Some of them you have to request access to the program, but there is a big list here. So, and one of the cool things that happened was that a few months ago, I think maybe even more than half a year ago, Anomaly Finder became a thing. But it was already for, I think, for a year in the cognitive services labs before it moved to preview and became general available. So you could have participated in shaping this project. So what can Anomaly Finder do? It uses machine learning to help understand abnormal events in data. So it gets input as a JSON with values with the timestamp and a value called points. So those things you send to the API, and it will give you output back. So it will tell you, hey, for this point in time, I expected this value, but I got this value. I would have found it okay if this value was between this lower margin and upper margin. So if it is not, I will classify it as an anomaly. And then of course the value can be a dip or a spike. And this is what you can do with it. So this is temperature data from an IoT sensor that normally should have, like, the room should be like around 20 degrees, because the blue is the actual temperature. And the yellow line is the temperature that it expected for that point in time. So you see that with a few red dots, those temperatures are not within the expected bounds and marked as an anomaly. So, and then of course you can write in your code, like, if this happened, then do this again for me. And one of my favorite projects is Project Gestures. It still lives in the Microsoft Cognitive Services labs. So Project Gestures incorporate the gesture-based controls in your applications. And that means that I can control my computer with my hands instead of with a keyboard or with a mouse. The only downside or plus side is that you need a compatible device to actually do that. So you need an old Kinect, a Kinect V2, or you need an Intel RealSense camera to do that. Basically, you need a camera with a depth sensor in it. So in opposite of all the other cognitive services, this cognitive service doesn't live in the cloud. It is an application you install on your local machine. And when you have this application installed, you can actually see that it is pretty good in tracking very fast the poses of your fingers. So let's look at the code. So in this example, with these few lines of code, we're going to first define hand poses. So a hand pose is a fist, all my fingers closed, and peace, these two fingers up and the rest folded. So you see my index finger and my middle finger have to be open and the other one's closed. I can combine those hand poses into a gesture, which is called make peace. I register that gesture at my gesture service that is actually running on the computer because I've installed that SDK on it. And then I can say, if make peace is triggered, say hello. So this is how it looks. This few lines of code in a UEP app can do this. So you see the Intel RealSense camera, my surface, and you see how fast it responds. If I do that, then it says hello. And I find that pretty cool. So you can do lots of great things with this project gestures out of the box, because you get gesture packs on your machine. So by default, you can control PowerPoint with your gestures, send emails, hang up Skype in a cool way, work in 3D space with your hand and move it, move things, control YouTube without bending or having a mouse, maximize it. Pretty cool. Add it to your favorites in Bing. And this is how you want to use Facebook. Swipe, 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 and like. And of course, it is pretty good in gaming. So I want to close down the presentation, so keep your questions coming. So cognitive services are a great way to kickstart an intelligent project. So if you want to achieve something and someone asks you, can you solve this with AI? Can you make this model for me? Can we do this speech recognition? First have a look if it is available in the cognitive services suite, because it will save you a lot of work. So what have we seen today? We have seen the Face API that can detect, identify faces. We have seen the Computer Vision API that can tell you what is on images, do OCR. We have seen Custom Vision, where you can create your own customized models without a single line of code. We have seen speech recognition, so you can talk to your computer and it will type it for you. There is speaker recognition that can identify speakers in audio streams, and there is real-time speech translation for it. You can just talk and it will subtitle you real-time in a different language. So if you want to learn more, you can go to my blog, henkboelman.com, follow me on Twitter, go to my GitHub, a lot of code examples there. So thank you very much, and let's have a look if there are any more questions. Okay, here. If iteration 4 is better than 3, 2, and 1, why would you want to test with the other one? Yeah, so I can test it against my test set, but it doesn't mean that that iteration is performing better in the real world. Is it possible to export the model and run it in an Azure function? If so, what language framework would be the best? Yes, you can do that. I actually have some examples for that, but you can use, for instance, Python functions to do that. Is an Xbox 360 Connect camera be used and is it compatible? No, that is not compatible. Read the Kinect V2. What do you need to get it connected and installed? You need that adapter kit to your computer. So basically, you put in the Kinect and then you get a USB cable that you can connect it in your computer in a USB 3 port. Would you run a separate session on deep learning? Yes, if you go to my YouTube, there are some sessions about PyTorch and on how you can actually create these custom vision models, classification models yourself. Are there any more? Oh, yeah, no. Okay, Emma, I think then we are done because I think I've answered all the questions.
Yes, brilliant. Thank you for getting through all of the questions, and thanks everyone for all of your questions. It's great to see them coming through. And Henk, I think you mentioned there's a way for people to connect with you after the session if they have any follow-up questions.
Absolutely, yes.
Yeah. Okay.
The best would be just send me a message on Twitter.
Okay, great. And I think that's on the screen now, right?
Yes. Yeah.
Brilliant. Okay, and thank you, Henk, so much for today's session. Really appreciate you coming on and delivering another session with us. Like I mentioned at the beginning, the session was recorded, so I will post that link on the Meetup Reactor London page within about 48 hours. So you'll see the link come up there. And if there are any other questions, feel free to reach out to Henk on his Twitter, or you can post them in the Meetup page too, and we'll get back to them. So hopefully see you all at the next session. Actually, before we go today, I have a very quick ask. We do have a survey for these sessions that would be great if you could go on to and leave your feedback. It's a very short survey. I'll post it now in the Q&A. There is an event code that goes with it, which I'll also post, but it would just be great to get any feedback from this session so we can learn how to, what you liked and how we can make them better going forward too. So that's just gone up in the chat there. But I think that's everything. Thank you so much again, Henk, and everyone who attended, and hopefully see you again at another session.
Thank you.
Bye. Enjoy your day.
You too.